Okay, so this will be, I guess, our last workshop session of the day. This is gonna be kind of different. I'm gonna talk about the live processing. So like I talked about yesterday, the live pre-processing is good if you want to monitor the quality of your data as it comes in from the microscope. So we can, in this session, develop a automated pipeline to go from the raw like data that you would obtain from your microscope all the way to particle picking, if you so prefer. And then we're going to demonstrate this on 3 different data sets live, and then one other very large data set that won't be demonstrated live, but I'll show you the results from that processing session. So the 3 different data sets, to recap, you will have seen the pre-processing performed on 2 of them. So the first one is the HIV-1 GAG spike protein, Empire 10164. We're going to do 2 tilt series from that data set. And then I'm also going to do a new one, which is purified ribosomes, so Empire 10304. That one has 6 tilt series that we'll process today, and the last one will be in situ ribosomes, which Abby also processed this morning. Empire 10499, and that one has 2 tilt series. And the one that I'm not going to show live, but just to like demonstrate the like capabilities of the live pre-processing, there's a membrane protein data set that we have, which has like 1300 tilt series, and like that volume of data is processable by our pipeline. Okay, so to start a session, you're going to navigate to the dashboard. I also want to just note that for people running on our instances, so Research Bartasagi Lab 09 or Research Bartasagi Lab 10, you won't be able to run the like live session stuff, so you can just like sit back and watch what I'll be putting in for parameters. But just note that the pre-processing steps are very similar to what Abby demonstrated this morning. So if you were able to run those, or like you understand those well enough, then like it should be a very simple jump to what is being done in the live sessions. Okay, so anyway, from the dashboard, instead of creating a new project like we did this morning, you're going to click on this button to go to sessions. And it's going to bring up this blank page of either you can start a single particle session or you can start a tomography session. So today we're going to do tomography, so I'm going to click the button. The first data set that we'll be processing will be the HIV spike protein. So I'm going to give it a name based on the Empire number. The group, like I talked about yesterday, if you're in a lab, you can have people split into different groups, and then based on the groups, you'll have different read access permissions for each of the sessions. So I'm in the Bartasagi lab, so we're just going to call this the Bartasagi group. As you type, the different group options will show up here. I'm going to go ahead and select that. So the location of the files, I click on this magnifying glass option, and I navigate to workshop. Because we're doing 10164, I'm going to click that folder, and I'm going to filter by the file extension that I want. So the files that I want start with TS underscore, and then I'm going to wildcard and ask for the TIFF files. And I click filter, and it brings me to 82 matches. I'm going to choose this file pattern, and then I can move on from the raw data. So just to reiterate, this was the path to the raw data that I used for this example. Now moving on to the gain reference, you'll see for Empire 10164, there is no gain reference, so we can move on there. The microscope parameters, the pixel size is 1.35 angstroms. The acceleration voltage is 300 kilovolts, and the tilt axis angle is 85.3. So the same numbers that Abby presented this morning, just reiterated. Okay, so session settings, this is the one of the tabs that isn't available in like your traditional pre-processing workflow. So this will dictate like how you want to copy your files from the microscope to your local cluster, as well as like some settings about like how long the session itself should run for. Okay, so the first thing I'm going to change is this timeout. Normally, you can leave this value longer depending on how long it might take your data acquisition to occur. But for the case of today, I'm just gonna set this to 1 so that the job finish, or like, the job will automatically end, if for whatever reason it doesn't end during the session itself. The number of tilts, so in this data set, you're gonna have 41 images per tilt series, so I'm gonna put that number there. And for the raw data option, I'm going to select copy, which again from yesterday means that you will have both a copy at your microscope and also on your network storage location. So you have the same data in 2 different places. And then just in case if I ever want to rerun something, I'm going to click restart transfer. What this button does is it basically pretends like the files haven't been copied over. So if I wanted to rerun file transfer jobs, it would just do like a new copy again. Okay, then I'm going to move on to frame alignment, which for this data set, I don't need to change, but I will demonstrate how this is changed later. So CTF determination, we're gonna go ahead and set this max resolution to 5 angstroms. Tilt series alignment, I believe the default parameters are good for this data set. You don't need to change them for any of the data sets that we're going to talk about today. So moving on to tomogram reconstruction, I also won't need to change any of the data or any of the parameters in this tab, so we can leave these as is. Subtomogram extraction, we don't do this during the live session, so you can just skip past this tab entirely. So for particle picking, however, because this data set has some like unique geometric parameters that we can exploit, we're going to go ahead and use this option in this tab. So I'm going to go ahead and set my virion radius to 500 angstroms and set the detection method to auto, which will bring up these 2 additional parameters here. We're going to leave these as default and then move on to the spike detection method, which I'm going to set to uniform. And again, this setting will bring out this these additional 4 subparameters that can control how you want the spikes to be detected. So firstly, we're going to change the minimum distance between spikes to be 8 voxels. And then we're going to set the size of the equatorial band to 800 angstroms. Next, moving on to particle detection. We're going to set the detection radius for the particles to be 50. But I do want to note that because we are doing, we're exploiting this geometry present in the way that the particles are present in the data set, you won't actually be using the particle detection parameter, but this will help in rendering the PIC particles. Okay, so training evaluation, this is our neural network method. Like I mentioned yesterday, you could conceivably, if you have a trained model, you can navigate the path to the trained model in this parameter box. Otherwise, it's not really feasible, or it doesn't really make sense runtime wise to train the model as your live data is being processed, because what will end up happening is your model training will take a couple hours, let's say, and that's much longer than the time that it will take for the session to finish running. So we're going to skip past this parameter for all of the examples we showed today. Okay, so on to resources. Like I mentioned yesterday, the general rule of thumb is that you want to have as many threads per task as you have images in your tilt series. So in this case, I have 41 images in my tilt series, so I want to set this threads per task to 41. But let's say I don't have 41 threads, let's say I only have 32. So what might happen in that case is you will need to run 2 different jobs, or your data will be split across 2 jobs. So in the first run, you'll process 32 of the 41 tilts. And then in the second round, you're going to go and process the 9 that were left over. So if you don't have enough threads such that each thread handles 1 image in your tilt series, your processing is going to be split into 2 batches. It will be slightly slower in that case because you can't take advantage of the full resource maximization. Okay, also like I mentioned yesterday, for memory, you want to set this value to be 4 times the number of threads you have. So 4 times 41 threads will give me 164 gigabytes to request per task. Other than that, the wall time you can keep as default. We won't need to change the CPU GPU partitions. Like I said yesterday, all of the live session stuff within nextPYP can be performed on the CPU. If you use any like external packages that require the GPU, like for example, Artomo, then this option will be utilized. Just to make things consistent, I'm going to change the memory per task for the pre-processing daemon to be 4 times the number of threads per task. But because these daemons, so here for the pre-processing daemon, and then here for the file transfer daemon, they're very lightweight jobs. You won't need as much resource allocation as you might need for the tasks that process your pre-processing tasks. Okay, so that's all of the settings that I wanted to change. Optionally, you can enable this verbose mode parameter, which will just allow for like more printout to be displayed when you're running your jobs. This can be helpful if you're like trying to debug like a failure that might have occurred in your pre-processing. But everything else is good to go. I'm gonna click save, and then this takes me to the operations tab. So I'm gonna go ahead and click start on the file transfer daemon. You'll see in the status, it's waiting to start, but eventually once it does, it will populate the file transfer information down here. So you'll get a graph of how fast each file is being transferred to your remote network, and then also a progress bar showing which files have already been transferred and which ones are still waiting to be transferred, or which ones are in process. Again, we can click the logs to see if there's anything outputted. You'll notice at the top that there's this command here, which is essentially the command line argument, or the command line command that you would use to run this if you didn't want to run it on the web interface. So you'll see here that it's submitting one job to do this. You can ignore these outputs for now. And you'll see at the bottom here that it was successful because it was entering the loop with timeout 1 day. So now that the files have been available on the network location, the data preprocessing daemon will start as indicated by the status here, and you can open the logs to see what's happening on this in this job. Okay, so now that I guess one entire tilt series has been transferred over to our cluster, we can then start the actual pre-processing tasks. So you'll see before there were no like tasks listed under this jobs heading, whereas now we have a size 1 job submitted. So the size 1 job corresponds to like one tilt series being processed, one tilt series consisting of 41 images. And the way that I can tell that this has happened is if I go to logs, you'll see that it has all the files for tilt series 01 on the network location. So it's added this tilt series to the queue and submitted the job that will process this tilt series. As the job is running, you can navigate to the different tabs here, and it will populate with information about like the stats, so like CTF, for example, the resolution of your tilt series data, as well as the estimated defocus. So I guess while we're waiting for this to process, I can show an example of what that might look like for a finished job. So this is the membrane protein data set. I'm gonna let the plots load for a while because it is a large data set. But you can see here, like it can transfer however many, like what is it, 1300 tilt series, and then in each tilt series you have quite a few images per tilt series. So it's able to transfer all of those files successfully. Okay. We'll let that load for a while. And then going back to the HIV data set, you can see the second round of tilt series images has transferred over. So accordingly, it launched another pre-processing job for that second batch. And again, if you go to logs, you can see that it's detected that all the images in tilt series 43 have arrived on the network. So they've been added to the job queue, and then a job has been submitted for these images. If you click on logs here, you'll be able to see the output of each of the jobs once they finish running. But while it's running, you won't be able to see the outputs here. Okay, so I'm going to let this run, and I'm going to go ahead and start another session for one of our other data sets. So going back to the session page here, next I'm going to process the purified ribosome sample. So this is Empire 10304. I'm going to click again, start tomography, give it a name. So the Empire identifier is a good one. For the group, again, I'm going to select Bartasagi lab. And for the file location, this time around, I'm going to use the set of MRC files. So again, I click on the magnifying glass, I navigate to our workshop data location, I click on the 304 folder, and I filter by MRC files. You'll see it takes me down to 6. I choose the file pattern, and then I can move on to the next tab. In this case, we don't have a gain reference for this data set, so I'm going to skip the gain reference tab. Moving on to microscope parameters. Here, the pixel size will be 2.1 angstroms, and the acceleration voltage will be 300 kilovolts. This tilt series happens to be aligned, so for the tilt axis angle, I'm going to go ahead and put 90. Again, for session settings, the session setting, I'm going to set the day timeout to be 1. And in this case, you might have noticed when I click raw data, there were other files there as well. Namely, there's a bunch of like raw tilt files or order files. So in this case, I can click this transfer additional files option, which will bring up this sub option, additional files to transfer. And I can specify any metadata that I might want to copy over to this session. So like I said, I want to copy the raw tilt files as well as the order files. You can list the like additional metadata just in like a comma separated list like I've done here. Or alternatively, if you don't want to specify the file names, you can instead select the number of tilts. You can select the tilt angles and provide like a comma separated list of tilt angles, like I've shown here, and the tilt order. So if you notice in the raw data here, it's like tilt 1, 10, 11, 12, 2, 3. You can provide that order under that parameter setting. But just for the sake of brevity, and I don't want to type in 41 different numbers, we're going to just use the transfer additional files option. Here, I'm going to demonstrate like what the link data transfer method might look like. And I'm also just going to select restart transfer in case, I want to, at any point, overwrite the data for whatever reason. Next, I'm going to go to frame alignment and just let the job know that this is a single file tilt series. And as I click this option, you'll see like these options have disappeared from the settings. So moving over to CTF determination, I'm going to set this max resolution to be 5 angstroms. Tilt series alignment, we leave as default. And moving on to tomogram reconstruction. So here I'm going to set a few different options. So firstly, I want to erase my fiducial, so I'm going to check that box here. And I'm going to set my binning factor for reconstruction to be 12. And then I'm going to click this show advanced options button up here, which will bring up all of these options that are highlighted in blue, which are normally hidden from this tab. I'm going to change the thickness of the reconstruction to be 3072. And I'm going to uncheck this resize squares box. So moving on, I'm going to skip subvolume extraction. There are no virions to be detected in this data set because it is ribosomes. So I'm going to go ahead and move on to particle detection. So for particle detection, I'm going to set the radius of the particles I want to pick to be 80 angstroms. And I'm going to change the detection method to auto. So under auto, I'm going to set some parameters here. So firstly, I'm going to change the threshold for contamination detection to be 2 standard deviations below the mean, and the minimum contamination size, which is the least or the smallest voxel like group size that we want to consider for contaminations. I'm going to set this to 60. I'm going to change the min distance between particles to 2, so any particles that are closer than this will be ignored. And I'm going to enable this local refinement parameter. I'm going to set the z-axis detection range to be 40 and select this particle detection threshold to be 2. And then we're not going to do any neural network picking. So then moving on to resources, I'm going to enable verbose mode for if I want to debug things later on. For now, I'm just going to hide the advanced options because we're not going to change any of those in the resources tab. The threads per task, because there are 41 images in each tilt series, I'm going to set this to 41. Accordingly, 4 times 41 is 164, so that's how much memory I want to allocate for each task. And for consistency's sake, I'll set this to 4 to match the number of threads here. So now I can click save. And in nextPYP, we have the ability to run multiple sessions at once. So it's like similar to how you can run multiple like different project instances at once. So I'm going to go ahead and click start on this. While it's waiting, maybe we can go ahead and see whether our other job is finished. So clicking on this eyeball icon here to open my session, I can see that this page has shown that no jobs are currently running. So if I click logs now, you'll see the output that's available for each of the 2 jobs that we had earlier. In the plots tab, you'll see, because it's kind of a small toy data set, this isn't very representative of like what kind of data quality information you might generate as you're running this session. So this one for now is kind of empty. But you'll see the table here, like these are very similar to the traditional pre-processing information that you might see. You can add your filters here. So let's say I want to filter by time, or let's say I wanted to filter by CTF score. I can set that here. Kind of a toy example, but I can apply and, delete filters, reapply filters. I can go to the gallery and get a preview of the different tilt series images, and then click on the tilt series itself to show what the tomogram reconstruction might look like. I can select the particles that have been picked, the virions, as well as the spike proteins, and then navigate my way through that tilt series. Similarly, for CTF information, I can look at this on a per tilt image for each tilt image, or I can look at all of them at once, or show all 1D plots for the CTF, and then navigate between images or between tilt series using these arrows here. I can look at how the tilts look for each angle as well, or I can show all of them for all the different angles, and similarly show the trajectory for each different angle. And lastly, the alignment. I can get a sense of whether or not my data is being tracked properly by seeing if the fiducials, for example, track this horizontal line. Okay. So the last data set that we're going to process today is in situ ribosomes. So I'm going to give it the Empire identifier name, so 10499. The group I'm going to pick is Bartasagi. By now, this should seem pretty straightforward and routine. The location, I'm going to take the workshop data, 10499, and I'm going to filter by the TIFF file extension, as shown here. Go ahead and choose that file pattern. In this case, the data does have a gain reference, which is this DM4 file. So I'm gonna navigate to the same location that I did for my raw data and pick this file up here. And in this case, the gain reference, we'll need to flip it vertically, so I'm gonna pick that option here. For the microscope parameters, we'll set the pixel size to be 1.7 angstroms. And the acceleration voltage to be 300 kilovolts, and the tilt axis angle to be 85.3. Again, with session settings, there'll be pretty similar to what they were for the HIV data set. So just gonna set this timeout to 1 day. There are 41 tilt images in each tilt series, so I'm gonna change the number of tilts to 41 and set the raw data transfer option to copy. Moving on to CTF determination. Here we're gonna pick the max resolution to be 8 angstroms. Tilt series alignment we can leave as default. For tomogram reconstruction, I'm gonna go ahead and select erase fiducials. And I'm gonna uncheck in the advanced options, this reshape tilt images to squares parameter. Again, there are no virions or spikes to detect in the data set because it is of just ribosomes. So I'm gonna move on to particle detection. And similarly, gonna set the detection radius to 80 as we did in the last data set, and the detection method to auto. And in the subparameters that this change will bring up, I'm gonna set the z-axis detection range to 80. Lastly, as should seem like pretty repetitive by now, the number of threads per task will be the number of images in your tilt series. So 41, 41 times 4, 164, 164 gigabytes of memory per task. Just gonna hide the advanced options for now and change the memory per task for the pre-processing daemon to 4. Hit save, and then start transferring those 3 tilt series images. So while this is running, go back and check on the status of our purified ribosome session. So here you'll see all 6 tilt series have transferred over. We're able to pick like 5,500 particles. Taking a look at the plots tab again, this one's a bit more populated because we do have more tilt series to process in this data set. So you'll have 1 bar for each of the tilt series that you processed today, as well as 1 point for each of those tilt series. Something I do want to highlight here is if you hover over one of these dots in this plot, it will give you a preview of an image from that tilt series, as well as like a summary of the estimated data quality for that tilt series set. And this image that's shown here is like randomly selected out of the available tilt images. Again, we can make filters if we want. We can add them here, apply them here, name it, save it, export it, load other filters. And in the gallery tab, you get a preview of what the tilt series look like. And then if you want like a detailed view of each tilt series, you can navigate to the tilt series tab and select the different tabs to view what you want, what statistics you might want to view for each tilt series. And then again in the reconstruction, you'll see the particle picking that we've performed live, just to emphasize. So as you navigate through the different stacks in your reconstruction, you'll see which particles have been picked. So just going back again. Okay. So lastly, let's go back to this job and see how it's running. You can see in the logs, it submitted this pre-processing daemon job. And if we go down to file transfer, you'll see that it's finished transferring a set of files for 1 tilt series. So because you have all the files from 1 tilt series, you can go ahead and launch a pre-processing job on that tilt series data. So this is what this is showing. So while this is running, I'm gonna go back to the purified ribosome data set and just demonstrate what these restart and clear options mean. So like I mentioned yesterday, restart is like a smart restart. So if I change, for example, under particle detection, let's say I think this is too many particles that have been detected. I want to increase the radius of the particles so that I get fewer particles, let's say. So if I change this to 90 and I hit save, then obviously I need to repick my particles, but I don't need to redo any of the stuff like tilt series alignment, CTF estimation, tomogram reconstruction. So if I go to operation and click restart, the smart restart will be able to detect that based on the type of change that I made, which steps should be restarted. So if I click on logs now, um, it will detect that this restart flag has been raised and correspondingly resubmit the appropriate jobs. So I'm just going to let that run for a while. So I guess while we're waiting for the restart flag to be detected, like I mentioned yesterday, the difference between restart and clear is that clear will like reset all of your pre-processing from scratch. So let's say for whatever reason, my CTF estimation was just way off and I can't really get any valuable like information from my tilt series data in that case. Because the CTF estimation has like a very strong role to play in downstream tasks like particle detection and tomogram reconstruction, it would make more sense in this case just to start everything from scratch. So if I wanted to change a parameter in my CTF estimation, instead of clicking this like restart option, I would click clear, and that would just relaunch data preprocessing from scratch. So anyways, going back to our example restart, you'll see here, so this was up to here were the outputs from our original run of pre-processing, but now that I've clicked this restart option, you'll see that it's detected this restart flag, and it's also detected which parameters have been changed. So in this case, the particle radius for particle picking. Then it's going to like change the value of this parameter in our session parameters and then re-queue our data to like resubmit the job. So in this case, because all of the tilt series data is already available on the local network or on the network location, it's going to add all of the tilts to the queue at once. And instead of submitting like 2 different jobs containing 3 tilt series each, it's going to just submit one job with all 6 tilt series. And you can check the status here. So this one will still show the output from our previous sessions, but once this job finishes running, you can then navigate and change or see the log outputs from there. So while this job is waiting to be run, let's go ahead and see whether this one is finishing. Okay, so this one is still running as well. But I guess like we've seen the results of pre-processing on the in situ ribosome dataset this morning. And here, when we change the settings, the job is still, oh, it's finished. Okay, so then we can go in and see like if any of the particles have changed as a result of tweaking this particle picking parameter. I guess the last thing to emphasize on the settings page is like to reiterate what these different buttons mean. So the eyeball button on the very left will open up your session page, starting with the like settings tab. If I click this one here, I can make a copy of a session. So let's say I want to make a copy of the HIV session. I can give it a new name. So 1064 V2, let's say. Hit copy, and then it will copy like all of my settings or my session parameters from that first session. The delete option will like remove a session. So we want to be careful here. If instead of copy or link like I've shown today, if you use the move option, this will like also wipe out your raw data. So just be aware of this fact and proceed with caution if you want to use this option. I'm not going to delete the session for now, but if I wanted to, I would just click yes here. And lastly, if I click this arrow, it will bring up a window that shows the file system location. So this is where any like session data would be written on our local cluster. I can copy this file path here and then like navigate to a terminal, for example, and then like CD to this path and explore what files might be written out there. I think that's everything that I wanted to copy or that I wanted to cover in the live pre-processing session. So if there's any questions, I'd be happy to take those now.
Thanks, Laura. I don't know if you got a chance to show like the watch, like, when the series come in as you're watching.
Oh, yes. So the watch option is like shown here in the tilt series tab. So what this does is essentially as you get new data, it will like update to the most recently processed one. So like let's say I was on like tilt series number 2 of 3, which wouldn't be the most recently processed one. If I use watch, it will take me to the most recently processed one.
Are any of your sessions still running to see if you can see like the new ones come in, or are they all finished?
I think they all finished. Yeah. Yeah, they all finished.
Okay, yeah, I was just trying to see if there was a way to demonstrate that, but I guess, yeah, it's fine. The only thing that you will see is that as new tool series come in, finish the pre-processing, they're gonna show up on the interface. Did you get a chance to navigate through the large data set?
Yeah. We can see, I think just because of like the size, it takes a while to display on the web interface. But in the presentation for the live session yesterday, you'll see like it's much more representative in the plots tab, for example. You'll have instead of here where I only have like 3 data points, it'll show like a bar, for example, for every tilt series image, or like a point for every tilt series that came in. But yeah, I guess just because it is such a large data set that it takes a while to like render on the web page.
Yes, but it shouldn't take that long. So maybe there's something else going on.
Maybe. Okay.
I think you were logged out.
I can. Yeah, there we go. Yeah, so you'll see like a lot more data for each uh tilt series in that data set. And like the table will show like however like what 1300 of my tilt series, and then I can create filters here which might be more like representative of the actual data that's being handled, and then I can filter and add other things to filter by. As well as in the gallery, I can get a preview very quickly of each of the tilt series. There's quite a lot of them. And lastly, in the tilt series tab, I can navigate backwards by 1, backwards by 10, backwards by 100, and like still show, some stats about data quality here.
One thing that we can probably maybe highlight or reiterate of the things that we talked about yesterday is when you have like collecting data using Beam Image Shift, and then you have multiple tool series coming in at the same time. Maybe you can just try to reiterate on that. How does that work with the resources that you have available?
Sure. So in the case where you'll have like multiple batches of data coming in, let's say your camera is over like one region of the microscope, you capture 25 tilt series, those get like copied over by this file transfer daemon will detect that, oh, all of a sudden I have like let's say 25 new instances of data to copy over. So it will copy that over, and then like they'll sit on my network location. And as I finish processing existing data in these Slurm jobs, it will like pull the new data from my network location and then process those. And then those results will get written to the website, I guess under like the plots tab or table gallery tilt series. the bottleneck, if you want to think about it that way, is like how many Slurm jobs you can launch at a time. So each Slurm job will process one tilt series. So if I can only launch 5 Slurm jobs at a time, for example, it can only process 5 tilt series at a time. So if I capture a region that has 25 tilt series, then it would take me like 5 rounds to process all the data that's received at once. But because the pipeline is automated, once you set up the settings, you can just like kind of set it and forget it, I guess. But like don't forget it if you want to monitor like the quality of your data, but like you don't need to go in and like change change settings after they've been set the first time, or like, you know, manually do the file copy yourself, or do this like job launching yourself.
Great, thanks. So I think we're out of time. We initially planned to have like an extended discussion after this session, but since we're going to have the session in the afternoon, maybe we should just break for lunch now, and then we can reconnect in about 1.5 hours. So just note that that meeting is a different Zoom meeting. So everybody should have received the link and the instructions on how to join that meeting. What we are going to do is we're going to leave this webinar session open, mainly so that we can try to answer questions or maybe problems that people run into while trying to follow the practicals. And then the Zoom meeting starting at 1:30, it will mainly be, you'll be able to talk directly to all of us here in the nextPYP team. We'll set it up using break rooms, so that way we have smaller groups, and then we can try to troubleshoot specific problems that people have run into, or we can try to clarify things that either were not covered or that people have questions about. So yeah, I think with that we can break now for lunch. Again, if you have questions between now and the start of the help session, just put your questions on the Q&A, and then we'll try to answer those before we start the session. And then during the session, you'll be able to obviously answer more questions that you may have. All right, thank you, Laura, and thank you everybody for all the practical presentations today. And we'll see everybody in about an hour and a half. Thank you.
Thank you.